Hiya, I'm Kaia, and I'm the mechanical lead for Robot in 3 Days at Purdue. I wanted to showcase some of the ideas that our team members had that didn't get to come to fruition just because we don't have time to try everything. Now, the first idea that I think we're going to see a lot this year is the expanding hopper with the intake attached. Now, if you want to visualize this, you should go check out 254 Cheesy Poof's 2017 Steamworks robot, because it's very similar to a lot of the robots that I think we're going to see this year. Now, if you aren't familiar with what a hopper is, it basically holds all of the fuel or whatever game piece you're working with that particular year, and it shuffles it into the shooter where it will get launched out of the robot. So, frame perimeter, you can only stay within your frame perimeter except you can extend over one side. Now, most teams are going to extend their intake over one side or have a split bumper intake. We chose to do an intake extending over one side because it gets you more area to collect the game pieces. But a lot of teams are going to go even further with that and allow their hopper, their fuel holder, to expand over that side as well. So people are going to do this in different ways. They're going to have some sort of sliding mechanism. We even had some ideas for a tilting mechanism where the intake wheel was actually mounted to the front of the tilting mechanism. The 254 one I mentioned, it had a sliding mechanism, kind of like a drawer that you just get to pull out, and you have that much extra space, about 12 inches if you design it correctly. Now, another idea that I think a lot of teams are going to use this year, there are two main types of shooter that I think we're going to see. One of which is just the two flywheels that you can operate separately because you're going to want some backspin on the fuel. And then the other one is a hooded shooter in which there's one wheel in the middle and a piece of material that can be adjusted or static on the back that allows the fuel to skate along it and shoot out at the correct angle. Now, one of the ideas that we spent the most time on was our indexer, and we actually ended up CADing it. So this is the initial drawings that we did for our indexer. And basically what would happen is you have an over-the-bumper intake, and then you have the fuel go into your robot, and you have some sort of pulley or chain in the middle that drags the fuel along the path of the robot. Now, this is difficult to do, especially when you're a short robot, because going under the trench, you have to account for 2 layers of fuel, plus whatever mechanism you had in the middle. For us, we had 2 layers. We thought we could fit about 18 to 21, maybe even 24 fuel if you use the intake as its own grabber. However, we were unable to complete this idea just because of how complicated it was and how little time we had to finish it. Now, I'd like to show you the CAD because I think it teaches some important principles on how you should go about your design. So, if you look at our Onshape, which I would highly recommend using as it's cloud-based, you go to Sketch 1. What you do is you make a layout sketch. So in this layout sketch, we have our chassis. It's really important to get your chassis dimensions correct because this helps you determine how you're going to stay in frame perimeter and how far you can reach before you hit your extension limit with your mechanisms. So we also included the height limit, which was for the trench because we really, really wanted to be able to fit under the trench. And then you base everything around those constraints. So you put the constraints in the sketch before you even start. The next thing is you want a bunch of your game piece so that you can kind of model how they move through your robot, because without that, you're just kind of making guesstimations. So as you see here, this kind of looks messy because there's a lot in it, but basically this was our old sketch that we had that we used as the layout, and then you can make side plates based on these layout sketches. So you just start adding holes that aren't construction because you want to make most of your constraints in construction, and then you add your motor holes and everything, and then all of a sudden you have a plate you can work with. Then once you have your main kind of space taking up mechanism, you can start adding onto that with more and more layout sketches. Now you'll notice that this one is blue and then there's a black version. In Onshape, black means that the sketch is fully defined, like I can't drag it and move it. And then blue means that I can drag it and move it. So we used this to figure out where our intake would sit and whether it could actually fold into our robot. Now this is a much older version of our intake. We did end up using a 4-bar, but it looks much different now. So we figured out via physical prototype testing that you guys saw earlier that the ideal kind of distance from the surface of your wheel to the surface of the ball is 4.5 inches by 4.5 inches from the floor and from the bumper. So we started by modeling the static version where it sits there, and then you can use constraints in Onshape to make an equal version that can actually move. So when we did this, we can now drag it and make sure it actually fits around our old mechanism, our old hopper mechanism, and then you can figure out where the motors are going to go, whether you have enough tolerance to actually make this happen, and whether it'll fold inside frame perimeter, things like that. So layout sketches are really valuable to use, and you can use them to make really cool things like an indexer if you have a little more time.